In problem 1.7, we are asked to integrate this equation. Dx by dt equals negative gt plus g times t0 plus v0. And we need to integrate it to find x as a function of time. And we are also asked to use the condition that the particle was at x0 at time t0. This condition must be used to evaluate the integration constant. So when we integrate this equation, we end up with an integration constant that can be evaluated with the help of this condition. And we are expected to show that x equals x0 minus half gt minus t0 whole squared plus v0 times t minus t0. So we are required to show this. This problem has nothing to do with chemistry. Honestly, it is just a mathematical problem, and let's get started with it. So I can write this equation as dx minus dt plus gt0 dt plus v0 dt. And now I can integrate this. I'm going to integrate this. I'm going to integrate it and we will get something like, I will get an x, negative g, integral of t dt would be t squared over 2, plus g t0, integral of dt is going to give me t, and this, plus a constant of integration. However, we know that at x equals x0, t equals t0. So it's going to be, because t is t0, right? So the constant c is going to be x0, and okay, so these two terms together will give us gt0 squared times negative half plus 1, which is half gt0 squared. Right, so c will be x0, or maybe just let me write it the other way so it's easier to understand. So you have x0 to be gt0 squared plus v0t plus c. Now I'm gonna just change the LHS and RHS. So I can write c to be x0 minus half gt0 squared minus v0 times t. So this is the integration constant. So we have done one part of the question that asks us to find the integration constant. Okay, now that we have found the integration constant, we have to show that x is equal to this value. So from our prior integration, the indefinite integration that we carried out, we have x to be equal to negative g times t squared by 2 plus g t0 times t plus v0 times t plus the integration constant c. Now I'm going to replace the c with the value we found out, which is x0 minus half g t0 squared minus v0 t0. Okay, I'm sorry, I think I made a mistake in the integration constant. I was supposed to write it as v0 t0. I think I wrote it as v0 t prior to this, so please make the correction. It's v0 t0. So when you find an integration constant, you do not have x or t in that. You only have, it's a constant, right? So you don't really have variables for that. It was my bad, it was a typo. It's supposed to be t0 there. So now that we have substituted it, let's see how we can show that this is actually equal to this. So let's bring x0 to the very front. X0. Now let's get the t squared or the t0 squared terms together. So I have g by g over 2 times t squared plus t0 squared. I've taken the negative g over 2 in common. And then I have g t0t plus, let me combine this term and this term together. That's going to be v0 times t minus t0. So looks like we have the x0 and the v0 terms, right? All we have to do is we need to show that this term here is actually equal to this term. And that's not that difficult because g t0 times t can be written as half times 2 g t0 times t. Now I can write it as g over 2, I can bring the g here, times 2 t0 t. Right, and if I did that, this term can be written as have a negative g over 2 times t squared plus t0 plus g over 2 times 2 t0 times t. Now this term, I'm going to bring the g over 2, a negative g over 2 common. I'm going to take that common, so I have t squared plus t0 minus 2 t0t. So this is nothing but, this is of the form a minus b whole square, where you have a squared plus b squared minus 2ab. So we have t squared plus t0 squared minus 2 t0. So this term can be written as t minus t0 whole square. So this entire term would be a negative g over, a negative g over 2 times t minus t0 whole square. So now that we have simplified this term, let's go back to the main equation and we can write it as x equals x0. And all of this term has been simplified to negative g over 2 times, sorry about that, negative g over 2 times t minus t0 squared. And we have this term plus t0 times t minus t0. So this is exactly what we were required to show from this, and we managed to show that. So we not only found the integration constant, but we also showed that when integrated and substituted with the integration constant, we end up with this value.